Hello friends, this video on Determinant Part 21 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched Part 1 to Part 20. Now let us understand a new topic called minors. What are minors? Minors are nothing but element of a determinant obtained by deleting its ith row and jth. So when I say minor aj, we remove the ith row and jth column. Whatever we get is the minor of that element, and it is denoted by mij. And also to note that minor of an element of order n, where n is greater than 2, is of order n minus 1. So for a matrix n of order n, the minor will be of order n minus 1. Unity is one level. That's how it is. I'll tell you how. For example, this is one matrix, right? Now for this, I want to find the minor of this. So minor of these guys is nothing but you remove this row, you remove this column. This guy is nothing but minor, that is mod of B2C2, B3C3. This guy will be called minor of ij. So here this is 1 1 element, this is M11, is this guy. And if you see, this is 3 cross 3 and this is 2 cross 2. So the order of this guy is 3 and the order of this is 2. One more example we can take. If you want to find the minor of this guy, then you have to remove these guys. So what you get is A1 C1, A3 C3. This guy is M. This element is 2 comma 2. This is 2 2. Also here also, if you see, this is order of 3 and this guy is order of 2. We can take one more example if you want. So let's suppose we want to find the minor of this guy now. Remove this guy and remove this guy. What you get is 2 minus 3, 1 5. This guy is minor of, since this element is the second row, second row, third column, M2 3. And this guy is also 2 cross 2 and this is 3 cross 3. So what you observe, minor is nothing but it's again a determinant which is obtained by deleting the ith row and jth column for mij. For example, mij is nothing but minor of an element aij. Correct? So this thing we have done, I think, when we wanted to find the determinant value, we did that. We circled this and remove the values from rows and columns. Similar thing here. And the reason why we are finding minor is this will help us to derive a formula to find the determinant for any order. I'll show you how to do that, but just understand the reason why we are learning minor is because with this we can derive the formula. We'll have a better mathematical representation of the formula. So, but if you remember, in formula we have minus I into I plus j, correct? Aij into this guy. Now if you see, this value is missing here because we are concerned only about the determinant we get by removing rows and column, ith row and jth column. This part is not considered. This part will be considered in a new term called cofactors. We'll learn that. Cofactors. Cofactor is nothing but minor with the sign. So the one I told you, this is minus I plus j and this guy is aij into determinant. That's how we used to find determinant. If you're not understanding this, please watch, I think, part 2 of the series. There I've explained how we are using this. And so this part was missing in the minor and that was included in the cofactor. So cofactor is nothing but minus 1 to the power I plus j into minor. So minor is represented by capital Mij and cofactor is represented by capital Aij. Please note, cofactor is represented by capital Aij and minor with capital Mij. Cofactor is nothing but minor with the sign. That is minus 1 to the power I plus j into minor. So let's take some example. So for this element itself, if I want to find minor, so I have to remove this guy row and column. So my minor will be minor 1 1 because this guy is first element. That will be B2 C2 B1 C3. But if I want to find cofactor, this will be minus 1 to the power I plus j 1 plus 1 into B2 C2 B3 C3. So this will be my cofactor. Similarly, let's take one more example. So let's say we'll take this point now. For this guy, again we have to find minor. So minor will be M12 because this guy is first or second column, and that value will be A2 C2 A3 C3. Correct, because these are the 4 values left. The cofactor will be A12, that will be minus 1 to the power 1 plus 2, that is 3 into A2 C2 A3 C3. So cofactor is nothing but minor with the sign. So if you see here in this case, this guy is having a negative sign. Similarly, if you want, we can find one more example we can take. Let's take this guy. This guy is nothing but A31. So for this guy, I will delete these elements. I'll get minor as minus 3504, and the minor will be minus M31. For this, if you want to find cofactor, that will be minus 1 to the power 3 plus 1 4 into minor, and that guy is 1 only. So in this case, you see the cofactor will be equal to minor. In this case, if you see, this will be cofactor will be equal to minus of minor. In this case, if you see, cofactor will be equal to minor. So some case the cofactor is equal to minus, some case the cofactor is equal to minus of minor, depending on the value of I plus j, whether it is even or odd. So I can say that cofactor is nothing but minor into minus 1 to the power I plus j. So it is minor with the signs. The reason for minor and cofactor, as I told you, you should study things only if you find reasons to study, else it doesn't make sense actually. So for these matrices, if you see, if I want to represent determinant in the mathematical term, see we knew how to find determinant. We know that no, you take this guy or you start with any row, you take this row, cut this guy, you find determinant, but there is no neat and clean way to write this mathematically, and that is the reason why we have got cofactor. So if you see, determinant is nothing but A11 cofactor A11, A12 cofactor A12, A13 cofactor A13. So this is a very clear representation. Also, since in this case we took row 1, we can also say, if I take row 2, A21, this guy if I take, then A21 plus A22 cofactor A22 plus A23 cofactor A23. Both are same. If I take a column, if let's suppose I take this column, I can say this way also, A13 cofactor A13 plus A23 cofactor A23 plus A33 cofactor A33. So this proof I have done, I think, in my video series number 2 for the same chapter. So the reason we have cofactor is it will give a better mathematical representation of determinant. So you can just write determinant in this fashion in the form of cofactor and minors. Also, we have to note that if the element of a row are multiplied with the cofactors of other row, then their sum is 0. This is just a property. For example, A11, A12, A13, these are all element of first row, and they are multiplied with element of second row, right? So if the element of first row multiplied with cofactor of second row, that is element of first row into cofactor of second row, and you add, this becomes 0. Not only first and second, if you take element of first row multiply with cofactor of third row, then also it becomes 0. Or you take element of second row, multiply with cofactor of first row, then also it becomes 0. Same thing applies to column also. In this case, we have element of first row multiplied with cofactor of third. You sum it, it becomes 0. Same thing applies for column as I told. For example, if I take in this fashion, in fact, this fashion if I take, so A12 into, and I take this for cofactor and this for element. A12 into capital A13 plus A22 capital A23 plus A32 capital A33. So this guy also becomes 0. Just a note, please note this. Now, having understood the reason for the cofactor and minors in our life, let's take some examples of minors and cofactor. So here we have to write the minors and cofactors of this guy, 2, minus 4 and 0 and 3. So if you see, there are so many minors and so many cofactors. For 1, 1, here minor 1, 1, we have minor 1, 2, we have minor 2, 1 and we have minor 2, 2. Similarly, we'll have cofactors also. So let's find minor 1, 1. For 1, 1, you take this guy, delete this and this, you get 3 as the 1, 1 minor. For minor 1, 2, you take this guy, you delete this row and this column, you get 0 as the element. So for minor 2, 1, you take this guy, you delete this row and this column, you get minus 4 as the minor. For minor 2, 2, you take this guy, circle this guy, you remove this columns, you get 2 as the minor. So I got minors. Now let me get cofactors. Cofactors I'll have A11, A12, A21 and A22. So cofactor 1, 1 is nothing but minus 1 to the power 1 plus 1, 2 into M11. This guy is nothing but minus 1 to the power 1 plus 2, 3 into M11. This guy is nothing but minus 1 to the power 1 plus 2 plus 1, that is 3 into M21. And this guy is nothing but minus 1 to the power I plus j, 2 plus 2, 4, M2. So this guy is nothing but minus 1 square is 1, 1 into M11, that is 3. This guy is minus 1 into M12, that is 0. This guy is minus 1 into M21, that is minus into minus 4 is plus 4. And this guy is 1 into M22, that is 2. So that is my answer. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.